Hi, it's Andy T here again. After my last video, it was suggested to me that it might be easier and might be nicer for people if I walked them through some of the electronics on the back rather than leaving you guessing what might be happening. So here we are. This is the back of Ecto, or the base of Ecto1a, and I will explain it to you. The whole thing is based on very small microprocessors called pickaxe, and I'm using two different types of pickaxe. I'm using a 14M2 and a 20M2 processor. Not a lot of difference in them really, apart from the 20M2s having more outputs. Basically the 14M2's got 10 outputs and the 20M2's got 15 outputs. They also have inputs as well, and inputs and outputs can be mixed together. Some outputs are dedicated for pulse width modulation, for things like the beacons that you see pulsing and modulating. So let's start at the beginning with the power supply. Power supply here is two 18650s. Now there's only one put on at any one time, so if I put this power switch here over to the left, it will bring on this battery, and if I put it over to the right, it'll bring on this battery. With the switch in the center position, everything is off. The batteries can therefore be because it takes a reasonable amount of power to run more than 70 LEDs and a sound amplifier as well, so it needs to have a bit of guts behind the power. So the power is given out at 4.5 volts. Being lithium ion, they're rechargeable. I haven't got a charger on board. They're charged off board, so I can just take them out and put them in a charger as I need to. But basically the power is then passed out via a bus bar connection to each, and then across individually to each microprocessor, which then reacts on its programming. So what each of these chips does is it's got its own set of commands as to what it does with the lights and inputs that are associated with it. So let's take, for instance, this wireless receiver board here. The transmitter, which is this little key fob here, transmits a frequency which is picked up by the antenna here, this coiled piece of wire, and then this trips the output to the chip. It doesn't matter which button I press, because I'm using what's called a VT output, verified transmission. So it sees, it doesn't matter which button I press, it sees that any transmission, and it passes that voltage up to the chip. The input goes from being a low point to a high point because a voltage is being applied to it, and it then carries out a command to apply voltage to the MP3 decoder. The MP3 decoder has sitting in it a TF card. So this little TF card has loads of space on it, and it's got the siren noise for Ecto1a. Now once that plays, the output from here is timed, so it knows how long the siren noise is, and as soon as the siren is finished, it turns the power back off again using this relay here. So this is a what's called a read relay. It's so it operates at very, very small voltages, but it can switch high currents. So that the output of this is via this blue connector here, and that goes out to the speaker up the top here. It's a 5-watt amplifier, and it's got on board volume controls, and if I want to skip on to the next track I can do that via here. But I've only got one track on here that I need, and that doesn't play all the time. It's only when I press the button in here. So what are the other chips doing? Well, as I've indicated in a previous video, this has more than 70 LEDs to control, and some of those LEDs are grouped together. So for instance, this 20M2 here is doing the front light bar, which has 14 LEDs in it. So I need it to have its own dedicated chip. This chip over here, for instance, is not only is it controlling some LEDs, but it's also controlling the billboards, which have 6 LEDs per side, and it's also controlling the motor to turn the radar antenna and the servo output, which controls another detector on top of the Ecto1a. Now, this 20M2 chip down here deals with all the sequential lights from the rear LED display, which I shall put down and show you here. There are 14 LEDs in this strip, and because they can go in multiple directions, as you can see, I need to have good control of these to actually to allow me to keep these all looking good. So here we have the rear top light bar. We've got some other green lights here. We've obviously got brake lights and other things down in here. The only thing I didn't illuminate was the number plate. Other than that, we have light bars going down the side with the Ghostbusters sign. We've got this ectoplasm detector here, which, as you can see, just takes a half sweep before returning. We've got the radar dish, which takes a few turns every so often. We've got a red beacon up here, and you notice the beacons, the light ramps up and then back down again, just like a rotating sweeping beacon would do. This is an aircraft strobe. There are another 2 aircraft strobes on the front. Good old Slimer over here, of course. We turn the Ecto1 around. Now you can see this top light bar with the 14 LEDs in it. There's another light bar below, and we've got 2 green spotlights, another green spotlight which is in the back of the wing mirror, and then on the front of the vehicle we've got the 2 amber beacons which are deliberately out of sync with each other, so you can see they warm up and ramp down again just like a rotating beacon would do. Just above them we've got the 2 aircraft strobes, and again they're linked in with this strobe up here, but we've also got obviously headlights and lots of other goodies going on. And if I extend the antenna and I press the transmitter, you can hear the siren going off in the background. Well, I'm going to just turn the lights off now so you can actually see this working in a bit of darkness, because that was also a request that was made to me, so you could see this all happening in the dark. I'll just gradually swivel this round so you can see that as well. And there we are. Right, well, thank you so much, and I'll take this opportunity to wish everybody a very Merry Christmas. Please stay safe.